We are on topic 14. The distributive property. If I gave Julia something to distribute, what would she be doing with it?
Giving it out.
Giving it out to who?
People.
If I asked her to distribute it to people in this room, who would she give it to?
Everyone.
Everybody. So when we are using the distributive property, it's a property where what is on the outside of the parentheses is given to every single thing on the inside of the parentheses. So go ahead and get your notes ready, line off. The distributive property. Don't forget to put topic 14 and today's date. You will learn to recognize a number on the outside of a set of parentheses as sort of a distributive set. And if we use the distributive property, then we're distributing what's on the outside of the parentheses to everything on the inside of the parentheses. So here, there are two terms on the inside, so we're going to give A to the B and we're going to give A to the C. But if there had been 6 terms on the inside of the parentheses, we would have still given the A to all 6 of those terms on the inside of the parentheses. So, because this is multiplication, you should understand that when a number is bumped up against a parenthesis, that is multiply. So, it's going to be A times B. You're going to drop the plus sign. If that was a subtraction sign, you would drop the subtraction sign. Or if inside the parentheses you went keep, change, change, if it was a subtraction sign, then you would still drop that addition, but it's adding the opposite, and you would have also changed the sign of the second number. After you give A to the B, we're also going to give A to the C, so that's going to be A times C. So it will be A times B plus A times C. Example 1. Four times 7x minus 3. Remember that we're going to give the 4 to the 7x, and we're going to give the 4 to the 3. We're going to distribute the 4. So what is 4 times 7? 28 x's, because that's 7x. If we have 7 x's 4 times, we have 28 x's. We're going to drop the subtraction sign. And now what is 4 times 3? 12. Would 28x plus a negative 12 be the same thing? Keep, change, change. Would 28x plus a negative 12 be the same thing? Yes. So you may have a different looking answer if you went keep, change, change already on the inside of the parentheses. Then you may have come up with 28x plus a negative 12, and that is still a correct answer. So you have to be conscious that anytime you have a subtraction, adding the opposite is still a correct form of that answer. Have to start thinking algebraically. Example 2. If I had 5 times 3a plus 2b plus 4, you still should recognize it as a distributive set if I have a number on the outside of a set of parentheses. So I know that I have to give the 5 to the 3a, I have to give the 5 to the 2b, and I have to give the 5 to the 4. I have to distribute the 5. 5 times 3 is 15 A's. If I have 3 A's 5 times, then that is 15 A's. I'm going to drop that addition sign. 5 times 2b is 10 B's. 5 times 2 is 10, but they're B's, so that's 10 B's. I'm going to drop that addition sign. 5 times 4 is 20, and this is the answer. Now, if I had more than one set of A's in here, we'd have to combine those like we did last week. If I had more than one set of B's in here, we'd have to combine those like we did last week. Or if I had more than just one set of whole numbers, we'd have to combine those. So that's where we're going with this, where you're doing the distributive property, but then when you have a list of numbers there, if you have like terms, you still have to put those together. So this is what that will look like. Example 3. If I had 3 times m plus 1 plus 2m. Remember, they're not going to put the 1 in front of that m for you. I have to distribute the 3 to the m and the 3 to the 1. Do I distribute the 3 to the 2m? No, because it's not inside of those parentheses. I only give it to the things that are inside the parentheses. 3 times 1 is 3m. I drop the addition sign. 3 times 1 is 3. I drop that addition sign and 2m because that is still part of my problem. And when you have that problem written out, you should see or identify that you have 2 sets of m's there. That those are like terms. So I should be combining those together. So what is 3m plus 2 more m's? 5m. Then you would drop the plus 3. There's no other whole number term to combine that 3 with, so this is the answer. Last one. That's a 3 marker slip, it's not a negative 3. So we'll do negative 2 values. Which you used to doing it with whole numbers and then with positive, so it's a negative one. I have to distribute the 7 to only the 3K and the 4. You will not distribute it to the 18K. It is not in the parentheses. 7 times 3 is 21Ks. I drop the addition sign. 7 times 4 is 28. And then I copy the rest. Subtract 18Ks. Once you do that, you should identify or notice that you have 21K and 18K. They are like terms, so we have to put those together. We have to combine them. Again, that sign in front of it is important because that tells you how you're going to combine them. So 21 minus 18 is 3Ks, and then you have this 28 left that you can't combine anywhere because it did not have a like term. So 3K plus 28 is the answer. The simplified answer. Any questions? Yes.
Why isn't it 21K plus 18 and how do you like 2?
Because this was in the problem, you dropped it. And even if we had changed it to add a negative 18, the signs are different and we would have subtracted. 21 minus 18 is 3. The higher one was positive, so it's positive 3. So even if you had done keep, change, changed, and used your integer rules, you would have still gotten the same thing. Because subtracting is really adding the opposite. So let's come up and add our notes to the side in case you're going to use your Cornell notes to study the way that you should. And bring out the original problem. That way, if you decide to cover up your notes and review your notes tonight and you try over here to solve these problems and you pull it down to see how you're doing each time, and if you are doing it correctly each time when you review your 4 examples from today, then you know that you're ready to go on and complete homework, whatever you didn't finish of classwork. Any questions about the distributive property? You're either going to distribute it and find that you have no like terms, and that's going to be your answer. Or you're going to distribute it and find that you do have like terms, and then you have to combine those like terms. Any questions? Okay, I'm going to pass out your classwork or your practice.